Hey friends, and a very warm welcome to this solution session for the number system exercise which I have uploaded a few days back. I got a lot of responses and most of you have done quite well in this exercise. Almost all of you have achieved around 70 to 80% scores, and many of you have also achieved 100% scores. Let's see the solutions and how to approach these problems step by step so that you are well versed with the best solutions available as well as you understand the answers of these problems. So our first problem says, which of the following have maximum number of divisors? What do we mean by maximum number of divisors? It means nothing but maximum number of factors, right? Because only factors can divide a particular number, right? So let's see how to find the number of factors. So let's take a number, let's take a prime number 13. We know it has only two factors, which is 1 into 13. So the number of factors would be 2 only. Let's take another number, a composite number, which is 24. It has how many prime factors? So when we write it in the prime form, we can write it as 2 into 2 into 2 into 3. So there are two prime numbers, 2 and 3, but 2 is occurring how many times? 3 times. Let's also write the factors of 24. What are the factors of 24? The factors of 24 would be 1, 24, right? These are the factors of 24. Now if we start choosing out of these 4 numbers, right, we would start making the factors. So if we choose only 2, so 2 would be the factor, right? If we choose 2 2's, so 2 into 2, 4 would be the factor. If we choose all 3 2's, 8 would be the factor. If we choose 3, again 3 would be the factor. If we choose 3 and 2, right, 6 would be the factor. If we choose 3 and these 2's, so 3 2's are 6, 6 2's are 12 would be the factor. And if we choose 3 and all these 2's, then 24 will be the factor. So all these would be the factors of 24. So how many factors? 1 2 3 1 2 3 4 5 6 7 8. 8 factors, right? Can we achieve this result in other way as well? Yes, we can. There is a trick of permutation and combination which we can use here, though we would cover it in P and C as well, but it would be handy if we see this trick here, right? So these are the factors of 24. Let's see how do we arrive at this number, which is 8. So these are 8 factors. So we can write this number as 2 raised to power 3, 2 cube multiplied by 3 raised to power 1, right? So power of 2 is 3, power of 3 is 1. In how many ways can we choose 2? We can choose 2 in 4 ways. We can choose either 0 2, 1 2, 2 2's or 3 2's, right? So there can be 4 ways of choosing 2. In how many ways can we choose 3? There can be 2 ways. We can choose either 0 1 and or 3 1. So the number of factors would be 3 plus 1 into 1 plus 1, which is equal to 4 into 2, which is 8. So in general, how do we find the number of factors? We write it in their prime forms and we see the powers of the prime numbers, and if the powers are p q r, the number of factors would be p plus 1 into q plus 1 into r plus 1 and so on. So this is the general formula for the number of factors. Now let's come to our question. Our question says, which of the following have maximum divisors? So let's write all the numbers in their prime form. 99 can be written as 3 square into 11, 101. So is 101 a prime number? How do we check? We find the square root of it, which is coming out to be 10 point something. So the next highest integer is 11. We'll check all the prime numbers from 1 to 11 whether it is divisible by any prime number. So is it divisible by 2? No. Is it divisible by 3? It's not. Is it divisible by 5? It's not. Is it divisible by 7? It is not. Is it divisible by 11? It is not. So it's a prime number. So it is written as 1 into 101. Next is 176. 176 is written as 2 into 88, which again can be written as 2 into 8 into 11, which is equal to 2 raised to power 4 into 11. 182 can be written as 2 into 91. So is 91 a prime or a composite number? Again we'll take a square root. So the next highest integer is, the square root would be 9 point something. Next highest integer is 10. So we'll check all the primes which are under 10. So is it divisible by 2? No. Is it divisible by 3? No. Is it divisible by 4? No. Is it divisible by 5? No. Is it divisible by 7? Yes, it is divisible by 7. So the number would be 7 into 13, right? Now we have to find the number of factors of all these. So the number of factors of this would be 2 plus 1, 2 plus 1 into 1 plus 1, which is equal to 3 into 2, 6. So 6 factors. The number of factors of this would be 1 plus 1. This would be 2 only, right? So the number of factors of this would be 2 only. So the number of factors of this would be 4 plus 1 into 1 plus 1, which is equal to 10. So it has 10 factors. And for this the number of factors would be 1 plus 1 into 1 plus 1 into 1 plus 1, which is 2 cube and which is 8. So the highest number of factors are for this number 176, which are coming to be 10. So answer would be 176. 176 is our answer. I hope the concept is clear how to find the number of factors. Let's go to question number 2. The question number 2 says a girl wrote all the numbers from 100 to 200, then start counting the number of ones that are used while writing these numbers. What is the number she got? So again this is a observation based question. We know that from 100 to 200 there are 101 numbers, right? Out of this the numbers which start with 1 are 100, 101, 102 up to 199. How many numbers are these? These are 100 numbers. Where do we get another ones? We get another ones from 101, 121, 131, 141 and so on up till 191. How many ones do we get? So these constitute 10 ones. And what next? How do we get some another ones as well? Yes, we do get some another ones from 110 when the middle term is 1. So first we are checking the 100th number. When is the 100th number 1? Then we are checking the ones place. When is the ones place 1? So this is checking the ones place 1. Now we are checking the tens place 1. So when is the tens place 1? 110, 111, 112 up till 119. How many numbers? 10. So total would be 100 plus 10 plus 10, which is 120. So our answer would be 120. Approach is, you first see the units, the hundreds digit, then you see the tens digit, and then you see the tens digit, and then you see the ones digit, or whatever you may find easy. Let's go to question number 3. Question 3 says LCM of two numbers is 280. So 280 is the LCM. 280 can be written as 4 into 7 into 10. In the prime forms, it can be written as 2 raised to power 3 into 5 into 7, right? So this is our LCM, and our numbers are given to be in the ratio 7:8. So let the numbers are 7a and 8a, right? So the first number is 7a, the next number is 8a. 7a can be written as 7 into a. We don't know whether a is prime or not, so we'll just write a, and this can be written as 2 cube into a. Now to find the LCM of these two, what do we do? We would find the maximum power of primes, right? So the LCM would be, we know for sure that 2 is prime, so maximum power of 2 is 3. So 2 raised to power 3, and maximum power of 7 here is 7, right? So this seems similar to our number as well. What are we lacking? We lack a 5, right? So if we multiply 5, we get the exact LCM. So let's substitute a by 5. If we substitute a by 5, our LCM would become this. So a has to be 5. So 7 into 5 is equal to 35. 8 into 5 is equal to 40. So 35 and 40 should be our answer. That's how you approach this problem. Or the easier way out is via options as well. So if you see the first option, here the LCM would be, if you find the LCM by the prime factors method, the LCM would be 7 into 8 into 10, which is equal to 560. In second case, LCM would be 280. In third case, the LCM would be 7 into 8 into 6, again greater. And in this case, the LCM would be 7 into 8 into 4. So our answer would be option B. Let's go to next question, which says, if we write down 259 to 492 side by side and get a very large number, how many 8s will be used to write this very large number? This is very similar to question 2, which we have just solved. I hope that all of you would be able to solve this question after you see the solution for question number 2. So the answer here is D. I leave it to you for your practice, and if you have any doubt, you can again discuss it with me. Question 5. If n is a positive number, which one of the following must have a remainder 3 when divided by any of the numbers 4, 5, 6, right? So one way is the LCM way, other way is the option way. The option way is easier. So any number which is divisible by 5 or 6 or any divisor can be written as dq plus r, where r is the remainder, right? D is the divisor and q is the quotient. So dq should be divisible by the divisor. So let's see whether 12n is divisible by 4. It is. Is 12n divisible by 5? No, it is not. So this cannot be the solution. Let's check 24n. It is again not divisible by 5, so it's not a solution. Let's check 90n. It's divisible by 4. It is not, right? So again this cannot be answer. Let's check 120 plus 120 and yes, it is divisible by 4, 5 and 6, and we have 3 as remainder. So our solution is option D. Let's go to next question. An observer observes that it gets a call at an interval of every 10 minutes from Pune, at every 12 minutes from Mumbai, at an interval of 20 minutes from Chennai, and after every 25 minutes from Kolkata. If in the early morning at 5 am it receives the call simultaneously from all the 4 destinations, then at what time it will receive the call from all the places on the same day, right? So again, we have solved this kind of question in our illustration video, but let's see how to approach this. So person gets a call at 5 am. Next he would get call from Pune at 5:10, then at 5:20, then at 5:30 and so on. From Mumbai he would get at 5:12, 5:24, 5:34, 5:36 and so on. So what are we trying to do? We are trying to look at the multiples of all these numbers. So and then we will find an LCM. So numbers are 10, which is written as 2 into 5. The next is 12, which is written as 2 square into 3. The next number is 20, which is 2 square into 5, and the last number is 25, which is written as 5 square. LCM would be what is the maximum power of 2 is 2. What is the maximum power of 3? It is 1, right? What is the maximum power of 5? Square, again 2. So LCM would be 300. So after every 300 minutes it would again receive call from all the 4 destinations. 300 minutes means how many hours? So 300 divided by 60, which means after 5 hours it would receive calls. So it received calls at 5 am. Now it would receive calls at 5 plus 5, 10 am. Then again it would receive call at 10 plus 5, which is 3 pm. But our option says 3 am. So B is not the correct solution. Only A is the correct solution. So we'll check A as an answer. Had it been 3 pm, so the answer would be both A and B. So the examiner has given B as 3 am just to trap the student so that he ticks an option D. But we'll be cautious about it and we'll tick option A only, right? Let's go to next question, which says the sum of 3-digit number is subtracted from the number. The resulting number is always, the question is incomplete here, always divisible by is the question. So the number, a 3-digit number, let's say it's ABC, it can be written as 100A plus 10B plus C. So this is the general form of how we represent a 3-digit number. For a 4-digit number, we would, if it is ABCD, we would have written 1000A plus 100B plus 10C plus D, right? But we are given a 3-digit number, so let's stick with 3 digits. So this number is, from this a number is subtracted, which is sum of these digits. So what is subtracted is A plus B plus C. We have been asked that this should always be divisible by what? Let's simplify this. We will get 99A plus 9B, which again can be written as 9 is common, 11A plus B. So as we can see, this is always divisible by 9, so 9 would be our answer. Very simple, but very much expected in our CSAT exam. Question 8 say if n is equal to 2 cube into 3 raised to power 4, m is equal to 2 square into 3 into 5, then the number of factors of n that are common with factors of m are. We have seen how to find the number of factors. Now let's look how to find the common factors. Now m contains 3 primes 2 3 5, n contains 2 primes 2 and 3. So only those factors of m which has 2 and 3 would be common with n, right? So let's see what factors of m are having 2 and 3s. So the factors of m which have 2s and 3s only would be one would be 1, right, which is common to both. The another factor would be 2. The another factor would be 2 square, right? So these are the factors which have only 2's. Now let's see what are the factors which have 3's as well. So it would be 3 only, because we have 3 raised to power 1 only in m. Now let's see if we combine 2 and 3. So there would be factor 2 into 3 which is common. There would be another factor 2 square into 3. Can we make any other factor from 2's and 3's only? No, we cannot. So these are the factors which can be made from 2 and 3. And since we have 2 square here and 2 cube in n, all the factors of 2's which can be made from m are factors of n. Since the power of 3 here is less than power of 3 in n, all the factors which contain 3 would be factor of n. So how many factors? 1, 2, 3, 4, 5 and 6. 6 would be those factors which are common with n. That's how we solve this question. Let's go to next question. It says the remainder when a positive integer m is divided by 7 is x. The remainder when m is divided by 14 is x plus 7. Which of the following could be m? The best way to solve this is through options. Let's check the options. First option is 45. When 45 is divided by 7, what is the remainder? The remainder is r would be, I am writing r for remainder, r would be 3. When 45 is divided by 14, what is the remainder? R would be again 3. So this is not our option, because here r should be 10. Let's see option 2. When 53 is divided by 7, the remainder would be 4, right? When 53 is divided by 14, what should be the remainder according to the question? It should be 11. So is it 11? Yes, it is 11. We do not need to check further options, because we don't have both A's and B's or all of these kind of options. So we can straight away tick B as in solution and move to next question. The next question says A and B are playing mathematical puzzle. A asks B which whole numbers greater than 1 can divide all the 9 3-digit numbers 111, 222, 333 up till 999, and B immediately give the desired answer. And the desired answer was, we have to find the desired answer. If we see these numbers can be written as A multiplied by 111. So 111 is a common factor of all these numbers, where A can be 1, 2, 3 up till 9. So what numbers would divide this kind of number? All those factors of 111 would divide this number, any of these numbers, right? So let's find the factors of 111. 111 we can see is a factor of 3 and 37. So these are two factors of 111. And the another factor of 111 is 111 itself, right? So B says this option, 3, 37 and 111. So V is our correct answer. In this way, I think most of the CSAT questions can be solved if we are vigilant and if we choose how to work with options or otherwise. And we can solve these questions, I think, in 12 to 15 minutes very easily with around 80 to 90% efficiency, and also sometimes with 100% efficiency. If you practice like this and you practice consistently, I'm sure you would achieve very good marks in your exam. All the best for your preparation. I hope that you enjoyed the video and you learned quite a lot of concepts from these videos. I'll upload other videos in on YouTube as well as in my course very soon. Thanks for watching the videos and all the best.